Now in this example, use the binomial series to determine the expansion 1 over 1 plus 2x raised to the power 3 up to the term in x cubed, isn't it? So the first thing you do, your binomial expansion is 1 plus 2x raised to the power 3. It must be in standard form, isn't it? So the standard form means this is reciprocal, isn't it? So it can be written as 1 plus 2x raised to the power negative. The negative sign means it is in the denominator. So if you have something like 1 over 2 raised to the power half, this is just 2 raised to the power half, but you put negative sign to show reciprocal. The power does not change. The power remains the way it was 3. Have you seen it? Yes. The power does not. It is the negative sign which implies reciprocal. Are we together? Good. Now, you've now written it in form of a standard form of a binomial expansion, isn't it? Now, if you look at this standard form of binomial expansion, it is in the form 1 plus x raised to power. Are you seeing? It is in the form 1 plus x raised to power n. So the binomial series we are going to use is a binomial series which uses factorial notation because negative 3 is not a natural number. Are you seeing that? So we must use a binomial series which uses a factorial notation. So it means, first thing you know here that when you have n factorial, that is n into n minus 1 into n minus 2 into n minus 3 until you reach 0 factorial, isn't it? So we start when you have 1 plus x raised to power n. The first one is when you have 0 factorial, 0 means there is no term in the numerator, isn't it? And our x is raised to power 0, isn't it? Then plus the next one, when you have 1 factorial, it means there is only one term in the numerator, isn't it? So that one term in the numerator is what? Is n, isn't it? Is n, then our x is raised to power that one, isn't it? Are we together? Yes. So 0 factorial, 1 factorial, the next one is 2 factorial. If you have 2 factorial, it means there are 2 terms in the numerator, isn't it? And those 2 terms are 1, 2, meaning n and n minus 1, isn't it? This is just a logarithm of mastering it, but we saw how it was coming about, isn't it? Then our x is raised to power that 2, isn't it? Are we together? Yes. We are moving again until we reach the term in x raised to power 3. Then you move again, it is plus. The next is 3 factorial. If you have 3 factorial, there are 3 terms in the numerator, isn't it? That is 1, 2, 3, meaning it is n minus 1 and n minus 2. So we have n into n minus 1 into n minus 2. Then our x is raised to power that 3. Are we together? Then our x is raised to power that 3. Having done that, we simplify, isn't it? Are we together? So here we have 1 plus x raised to power n. 0 factorial is 1, x raised to power 0, anything raised to power 0 is 1, isn't it? So it means the first term is 1, the second term here is nx. 1 factorial is 1, x raised to 1 is x, so nx. So it means the first 2 terms of the binomial expansion you use 1 plus nx if you have this kind of binomial expansion, isn't it? Then you go to the third term is n into n minus 1 over 2 factorial, then x squared. Then the fourth term is n into n minus 1 into n minus 2 over 3 factorial, then x is cubed. So that is more simpler, isn't it? Having written that, you now compare it with your series. What was your series? 1 plus 2, 2x raised to negative 3. So to make this x different from this, meaning this other x in the general formula, you make it x1, isn't it? Are we together? The x in the general formula, you make it x1 to make it different with the x you have in the problem. So your formula, you now put x1. Is that okay? Yes. So you can now see, you can now do the substitution, meaning 1 is the same as 1. We are only dealing with, it is the only x value and n we are substituting, isn't it? Yes. Are we together? Yes. Because you can see from here 1 is just 1, and the position which x1 is occupying is being occupied by what? Positive 2x, isn't it? Then your n, the position of n is occupied by what? Negative 3. So it means where there is x1, we are going to put 2x, isn't it? And where there is n, we are going to put negative 3. Are we together? Yes. Good. So here we have 1 plus n times x1. N is negative 3, x1 is 2x. So you substitute that. Are we together? Move to the next one. Plus n is negative 3. Then n minus 1. Negative 3 minus 1 is negative. See, negative 3 minus 1 is negative 4. Yes. Over 2 factorial, isn't it? Then x1 squared. What is x1? Is 2x squared. It must be in bracket because the whole 2x, the whole of that value is x1, isn't it? Anything you are substituting must be in bracket so that you don't mess with the signs. Okay? You go on. The last one here plus n is negative 3, isn't it? Then here negative 3 minus 1 you get negative 4. Then here negative 3 minus 2 you get negative 5, isn't it? Then everything over 3 factorial. Then your x1 we found is 2x. Then it is raised to power what? Your x1 is 2x. So have you seen you substituted everything? Are we together? See, the next step is to simplify. Okay? So start here. This is equals to 1. Then negative 3 times 2x you get negative 6x. So you dealt with that term, you dealt with that term. You go here. So go here. Go stepwise. Go stepwise. Negative 3 times negative 4. What do you get? Over 2 factorial. Just move. Then here. We are separating there. 2x is squared, meaning both of them are raised to power 2, isn't it? So if you separate, you have 2 raised to power 2 and x raised to power 2. So can you now go to your calculator? What is negative 3 times negative 4? 12. 12 divided by 2 factorial? 6. 6 times 2 squared? Are you saying we are moving in order? Yes. 6 times 2 squared? 24. So it means there you found is 24. Then your x is raised to power what? See, x is squared. Yes. See, you simplified the whole of it. Are you seeing how it is easier to simplify? Good. You move to the next term. We are done with that term, isn't it? We are done with that. We move to the last one. So last one, go to the calculator again. Negative 3, isn't it? Yes. We have negative 3 times negative 4 times negative 5. Then after that, we divide by 3 factorial. Then separate this. Both 2 and x are raised to power 3, isn't it? Meaning it is 2 cubed times x, 2 raised to power 3 and x raised to power 3, isn't it? So let us go. Negative 3 times negative 4? 12. 12 times negative 5? 60. Negative? 60. Negative 60 divided by 3 factorial? Negative 20. Negative 20 times 2 cubed? Negative 160. Negative 160, isn't it? Good. Obviously we are moving stepwise. So we found the whole answer is negative 160. Then our x is raised to power? Our x is raised to power 3. To go pamoja? Yes. You move stepwise. Negative 3 times negative 4, you get 12. 12 times negative 5, negative 60. Negative 60. Is that negative 60? Meaning the person who used calculator did not give us the right answer. Whoever was pressing that in the calculator, that is wrong then. You did not get the right answer. Look here. Negative 3 times negative 4 is what? 12. 12 times negative 5 is? Negative 60 divided by 3 factorial. Negative 10. Who gave us negative 20? Negative 10. Negative 10 times 2 cubed? Negative 80. That is the right answer. So it is negative 80. Then our x is raised to power 3. I want you to be very keen when you are pressing those values in the calculator. This is not 3. This is 3 factorial, which is 6. Are you seeing that? That is 3 factorial, which is 6. You have to be very keen when you are dealing with the calculator. So we have actually expanded that expansion in the binomial series. So the binomial series we were using is the one having factorial notation because our power is not a natural number, isn't it? Are we together? Good.